I'm starting out with a very basic power supply, and then later on I'll be moving to more efficient power supplies. So this is just a very simple one which isn't particularly efficient, but what I'll do is I'll go through the features of it and show it working, and then I'll show inside what's inside the power supply, and then finally I'll go through the circuit diagram and explain how it works. So if I plug in the power, so I'm just running this off of some lithium ion batteries as a 12-volt input, and I've got my little projector which I've used in previous projects, and I'm going to be using it in later projects as well, which is just a volt and current meter, but this actually has several more features now because I've added some additional features. So it shows the watts and the ohms of the actual circuit, and then it accumulates amp hours and watt hours. And there's some configuration things I can do on the next two displays. And at the minute I've still got an issue with the current, even though there's no current flowing, it shows 28 milliamps. But I'll sort that out in a bit later. It's probably to do with the way I'm driving it from an op amp. So I've got an array of LEDs as a test load, and if I just put them in the terminal posts of the power supply, and I can turn, before I switch the power supply on, I can turn it up to 5 volts, which is what it runs at, and then just press the button and it turns on the LEDs. I've got a current trip up here, so I can turn this down until it trips the supply. So that runs at a quarter of an amp. So now it's set that if I reset the power supply without a load, if the P means that the power was interrupted by the trip. But now if I switch the power on and try and connect this straight away, because the current trip's set to below what the threshold is, it automatically trips. So you can set a current trip so that you don't get like an overload of the circuit that you're trying to test. But I'll turn that right up so that it doesn't trip again. And reset and switch on. And so it shows how much current's been drawn and the voltage. I'll just turn that up to about 5. It's about quarter of an amp at 5 volts. And if I go across, it shows it's just over 1 watt. 22 ohms is the effective load, and it accumulates the watt hours and amp hours whilst it's on. But because I've got the float, if I switch, if you press the button, you can reset the accumulated watts and amps. So inside the device, you've got the wires connecting all the controls to the circuit. But if I just pull all these off, there's not actually that much on the circuit. So you've got a microcontroller which does the all the measurements of the volts and amps. It doesn't really do anything other than that. It switches the circuit on and off. You've got op amps. The op amps are there to drive the voltage and current reading on the analog to digital converters on the microcontroller, but they're also there to compare the current and trip a relay. So the power comes in for a fuse and then goes for a relay before it goes to the rest of the circuit. And one of the op amps is used to compare the current with what's actually set as the trip current. And if the trip current trips, then it switches the relay on, and the relay latches up to prevent any power going into the circuit. And then the final op amp, so I've got a quad op amp here and I'm using all 4 op amps. The final one is to set the actual voltage of the power supply. It's just done as a basic, driving a Mosfet to regulate the power to whatever's set. I've got a resistor here as a current shunt, which I'm using to read the current value. And then I've got another Mosfet here which switches the power of the output on and off. So this Mosfet, which regulates power, has a heatsink on because it gets quite hot because it's trying to regulate the power. But this Mosfet doesn't need a heatsink because it's either fully on or fully off, and when it's fully on, there's very little resistance in the Mosfet, so it doesn't actually generate much heat at all. So I've got a 12 volt supply coming in. It goes through a fuse, a 2 amp fuse, and then it comes into a relay. So the power always goes through this relay here, and that's to allow for the current to be able to trip the power and completely cut off the power. So the power by default comes in along this power rail here, and the trip mechanism works by this op amp here. It compares two voltages, one coming in here and one coming in here. This one off of the variable resistor. It's variable between 0 and 5 volts. So if I scroll across to the right, I've got a 5 volt regulator over here, which supplies one of the compared values along this line, and the other value it compares comes out of the microcontroller here. Well, it goes into the microcontroller because it's the current sensing which goes into the microcontroller on that analog to digital line, and it comes up along here. And so because it compares those two values, which can be anywhere from 0 to 5 volts, when this lower value, which is current sensing, rises above whatever the user sets on here, the output of the op amp will switch, which will switch this transistor, and when that transistor switches, it will take the positive voltage up along this line, which will go back down through the coil of the relay, switch the relay on, and so tripping the circuit. So the relays will switch down to this point, this line here, and come up. And because the positive line is now coming in through the relay, and it's automatically going back through the coil itself, the relay latches up and it just stays switched on, which is why I've got this switch here. So when that switch is pressed, so that's normally connected, and when it's pressed, it's open circuit, and that releases the relay and will reset the power back onto the power rail again. So that's the way the current trip works. And so going past the current trip circuit, so normally there's power coming in along this rail here, and that powers up the op amps, and also powers up the 5 volt regulator, like I was saying over here. The 5 volt regulator just powers the microcontroller, so it provides a constant value which you can use for that analog to digital conversion, and also it powers up the display just down here. So that's what the 5 volt regulator does. And the microcontroller and the display, they just there for reading voltage and current values and displaying them and switching the circuit on and off. I use this switch over here to allow it to function the microcontroller, go through all its different modes, and allow it to power the circuit on and off. So this first op amp that we come to here, that's one of the inputs. The positive input there is a varying voltage which the user sets between ground and this is a 10 volt Zener diode, which provides a consistent 10 volts at that point. So the user can vary anywhere between 0 and 10 volts, and this op amp actually takes feedback from the output of, this is the regulating Mosfet which I'm using, and whatever the output is, so the input is the 12 volts in, the output is fed back onto the negative side of the op amp, and that regulates the output of the Mosfet at whatever the user sets on this variable resistor over here. So that provides the output, the actual output power. And you can see there's no Mosfet over here, which is the Mosfet which can switch the power on and off. So the output of the circuit is the feed is taken up here and into this op amp, where that's the that places an input into the microcontroller for sensing what the voltage is of the output of the circuit. And the actual circuit, the voltage output of the circuits, after it's switched on or off, at that point it goes to the output connector over here. So that's the voltage out, and on the ground path to that connector there's a shunt resistor here which measures the current So this wire that comes back around here goes up and into the current sensing. So if I scroll back a bit, so it'll come up here and goes into the op amp for the current sensing. But this op amp here is not configured quite correctly yet. I need to go through that circuit and make it a bit better, because if you noticed in the video, there's always a consistent 26 millivolt even when there's no current flowing, but when it goes above 26 millivolt it seems to measure okay. So I need to review that circuit. That's not quite correct on how that operates. And finally, this MOSFET, which switches on and off the output, that's switched on and off from this transistor here, which is switched on and off by the microcontroller. So the microcontroller and display, they could just be displayed, replaced as a volt and amp meter and a switch to switch on and off the power. But it's a very simple and basic power supply circuit. There's not much to it. It's not particularly efficient. It's quite an inefficient way of providing power. But in later attempts, what I'll do is I'll try and make this a lot more efficient at supplying power.